To begin our natural disasters wildfire module, we'll start with the basics. What factors influence how wildfires burn? Wildfire can occur in many different places. Grassland fires in Calgary killed hundreds of cattle, as well as destroying rangeland and property. This is a fire in the Siberian forest from late July in 2020. You can see the flames moving across the ground, almost looking like lava, but the treetops themselves seem relatively unimpacted. Earlier in this year, fires devastated vast areas of Australia. And even in the Amazon tropical forest, there are almost 7,000 fires burning in August 2020. All these landscapes are really different, but they're all susceptible to wildfires. A fire needs three things, and those things can be described by what's called a fire triangle. In addition to the fuel, a fire needs heat and it needs oxygen. If a fire doesn't have all three of these, it will die out. The quantity and the quality of fuel determines if a fire spreads. There are different types of fuel, and we'll talk about this more shortly. Fuel can only light if it is warm enough to start burning. For example, wet fuel doesn't light very easily, so dry conditions really help. Fire also requires air that has at least 16% oxygen that's needed to sustain a flame. Our atmosphere is currently 20% oxygen, so fresh additions of air would be needed constantly to keep a fire going. Wind contributes by providing fresh air oxygen. And another example is if you're lighting a campfire or a fire in your fireplace at home, waving on that fire or blowing on that fire can produce a wind that provides oxygen that helps those flames ignite. So as long as there is enough of a breeze and it's relatively dry, having fuel available is the main thing that might influence a wildfire. So let's talk more about the different types of fuel. Fuel is something that all fires need, and fuel loading is the amount of fuel that's available. There are different types of fuel in the landscape. Fuel that is buried in the ground, fuel that is on the surface, aerial fuels that are in the higher branches and the treetops, and ladder fuels, which can allow fires to move from the surface up into the treetops directly. Which of these fuels do you think would catch fire the easiest? What types of fuel might lead to fire spreading more rapidly? Which fuels would be the easiest to control a fire in or put out the burn? I've left a poll for you so that you can test your predictions and see what everybody else thinks about these questions. Ground fuels are compact as a consequence of being buried, so fires burning in the ground spread much slower than fires burning elsewhere. Rather than race, they smolder or creep. They may burn for days at only a few inches an hour. Such fires are so compact and so insulated that they can be hard to put out and can burn on even through winter snows. However, these fuels don't burn unless they're relatively dry. Ground fuels are important to consider during mop-up operations, when making sure the fire is out, or when constructing fire breaks and fire lines where efforts may be undermined if ground fuels are in play. An extreme example of how hard it is to put out ground fires is Centralia, Pennsylvania. In this town, coal seams in an old underground mine caught fire in 1962, and they've continued to burn ever since. The government was unable to put the fires out, so instead it paid to relocate people because the fumes and the sinkholes were so bad. Surface fuels are the materials that are on the ground surface. When they are dry, they are easy to ignite and they burn relatively quickly, such as grasses and sticks or downed wood. Surface fires move rapidly across the landscape because the fuel ignites quickly. Since there's not much fuel and it burns out quickly, the fire never gets that hot. For the fire to move out of the surface and up into the treetops, it needs ladder fuels. These are small shrubs or trees that allow the fire to step its way up into the larger trees and the branches in those trees near their tops. Here are some examples of a forest with ladder fuels. You can see small shrubs and young trees right next to larger trees. If these small bushes catch on fire, the flames could move up easily into the taller trees, even though their lower limbs are not that close to the actual ground surface. You can see this happening in this image where a fire on the ground, maybe because of these downed logs, has moved into some small trees and caught them alight, and now it's moving up into a much larger tree. Once a fire gets into the treetops, it's very hard to control. One of the factors that influences how fast a fire spreads in the treetops is the type of canopy cover, if you have open canopy or if you have a closed canopy forest. In an open canopy where trees are widely spaced, individual trees may be consumed, which is a phenomenon called torching, but the fire rarely spreads from one tree to another unless really strong winds blow. Instead, the surface fire usually runs faster than the fire among the treetops. This is what torching looks like. If the torch tree is close to other trees, then it can spread into the canopy and become a crown fire. But if the torch tree is sort of standing by itself and not next to other trees, then the fire may never move into these other treetops. It might just be this one tree that ends up burning down. In a dense or a closed canopy, the opposite is true. Closed canopies higher than 6 feet promote aerial fires the best. This allows oxygen to get in under those flames in the treetops. Very few fires do this, but those that do become ferocious tree eaters that consume whole forests in the blink of an eye. Closed canopy fires are also called running crown fires. They spread independently of and often faster than the fire at the surface. Understandably, these fires are very serious and dangerous, and they're very, very difficult to control. Canopy fires have another important behavior that influences the progress of fires as a whole, called spotting. Firebrands can be carried by the wind out of flaming trees and land far away, and these burning embers themselves can start these small spot fires, which could then grow and advance. These firebrands are one way that fires spread. This tree burned down completely after being set alight by a burning ember that was carried from a nearby fire. Nothing else around the tree burned. Firebrands can also be a reason that a roof of a house might catch on fire, even when nothing else around the fire is burning. Convection of hot air or flames is also a way that the fires can spread. Convection is just the movement of the air or flames based on their density. Convection of hot air works to catch things on fire even when they're not directly in the flame. Whether or not something will catch on fire depends on the radiant heat. This is based on how close it is to the fire and also how intense the fire is. Think about roasting marshmallows near a flame. That marshmallow can burst into flames even though you didn't put it directly in the fire. This is another way that some houses might catch fire in a wildfire. If they're close to very intense and hot flames, the heat itself might cause the house to catch on fire. Whether or not a fire becomes severe or not can influence what happens in subsequent fires, so it leads to what we call feedbacks. A severe fire where the canopy burns means that the vegetation that regrows will mostly be shrubs and small trees. Thus, the next time a burn occurs, it will likely burn all the vegetation because it is all low-lying and similar in height. So in both cases, you have very severe fires. In contrast, after a fire that is not as severe and there's vegetation that hasn't been completely burned, you might still have some canopy intact, you've had reduction in the surface fuels, there might be some regrowth of small trees and low-lying vegetation, but it's still likely that the next fire is going to be relatively small because there's not that much surface fuels available, and it's not going to get hot enough to necessarily burn up into the canopy again. Some of those small trees could act as ladder fuels, and so you could lose some more of those trees. But again, the spacing is probably not as close together as they might have been originally. And so you're not unlikely to lead into this running crown fire situation. Thus, severe initial fires are likely to lead to subsequently severe fires and also to have substantial changes in the ecosystem. In contrast, low severe fires are unlikely to lead to high severity fires in the future, and the ecosystem is much more likely to remain similar. Weather conditions can help start a fire and influence how fast it spreads. Hot, dry conditions increase the danger of a wildfire starting. Windy conditions can increase the likelihood of it spreading. At the same time, fires can actually create their own weather by creating what are called pyrocumulus clouds. These lead to dry lightning and strong winds that can help spread the fire further. In rare instances, fires can create what are called firenadoes, which are like a tornado of fire. A firenado that developed in an Australian wildfire last year led to the death of a firefighter when it flipped his vehicle over. So, as you reflect on the material that we have covered here, you should be able to address the following questions. What factors allow fires to burn? What are the different types of fuels, and what role do they play in a wildfire? How do wildfires spread? And what role does weather play?